it says to list two metals that could be used for pipes to transfer dilute sulphuric acid in a chemical factory. Now note the word list. When you're listing, you just name it or identify it. We have copper, silver and potassium. Now they're written in their chemical formulas. You can write it as their name, like say copper, silver and platinum, but it depends. So if you want to write it like that. But then if it says to name, you should always write the full name. In other words, you should write copper, silver and platinum. Question 15. Which metals react with cold dilute hydrochloric acid but not cold water? Explain this difference in reactivity. Now magnesium, aluminium, zinc, chromium, iron, cadmium, cobalt, nickel and tin. All these react with cold dilute hydrochloric acid but not water. The valence electrons are held into tightly, and the energy necessary to release them is provided by the reduction of the hydrogen in HCl, but not by the reduction of hydrogen in water. Now this is the chemistry behind it. So what happens is the valence electrons in these metals are tightly held, but with the reduction of the hydrogen in the hydrochloric acid, that energy is being provided by that reaction. But the reduction of hydrogen in water, that energy is not sufficient to release these valence electrons. So that's why these metals react with acid but not water. Moving to question 16, it says, based on the observations in the above table, deduce the order of activity of the four metals tested, starting with the most active metals. Now note that it says deduce, that means you have to extract your information. So we have calcium, magnesium, zinc and copper, and this is in order of its reactivity. Calcium and magnesium both are from the second group, while zinc and copper, they're in the middle. So we have calcium being more reactive than magnesium because it's towards the bottom of the periodic table. So if you move to your left towards the bottom, that's where you find the most reactive metals. And these are two in the middle, so they're not as reactive as these two. Moving to question 17. Now question 17 has three parts. The first part is to write a general equation for the action of metals of dilute acid. So when a dilute acid reacts with a metal, what happens is a salt and hydrogen gas is being produced. And this is our general equation. It's not written in chemical formulas, it's just written in words. The second is water. Now this is from last lesson, so you have to kind of flip back your memory. When metal reacts with water, it would form hydrogen and a hydroxide. So it will be a metal hydroxide. And the third one is with oxygen. Now oxygen was 2 lessons back, if you remember. So when a metal reacts with oxygen, it would just form a metal oxide. Now this is also known as a synthesis reaction because it's from 2 to 1. Now moving to question 18, it says, write word and balanced formula equations for the action of dilute sulphuric acid on calcium. Now we know calcium is quite reactive, but it's not as reactive as sodium, potassium. So when calcium reacts with sulphuric acid, it forms calcium sulfate. Now the sulfate is from the sulphuric acid because remember it's H2SO4. Now this part is a sulfate, calcium sulfate plus hydrogen. Now you have to write a balanced formula equation as well. When you're writing it, you have Ca, which is your calcium, reacting with your sulphuric acid. Now the formula for sulphuric acid should be known, and just memorize it as H2SO4. And then we have calcium SO4, calcium sulfate, which is CaSO4. Now calcium has a valency of 2 plus. Sulfate, remember I told you, has a valency of 2 minus. So when you write it, they just cancel out and you don't have any subscripts. But so calcium is found in the second group. That's why it has a valency of +2. And we have hydrogen gas also being produced. Now moving to part B. Part B says potassium. Now potassium is quite reactive. It's more reactive than calcium. So potassium with sulfuric acid would give you again potassium sulfate and hydrogen gas. Writing that as a chemical equation, we have two molecules of potassium reacting with sulphuric acid. When they react, they form potassium sulfate and hydrogen gas. Now note the potassium sulfate, the potassium has a subscript of 2. Now that's because potassium has a valency of 1, sulfate has a valency of 2. So when they cross over, the potassium goes 2. So K2SO4. Moving to question 19 now, write word and balanced formula equations for the action of oxygen on sodium. Now this is from our lesson, 2 lessons above. So we have sodium reacting with oxygen to form metal oxide, sodium oxide in this case. So if you're writing your chemical equation, sodium reacting with oxygen to form sodium oxide. Now this is good revision for your chemical equation writing because this is part of the topic. So again, when you're balancing equations, if you remember, you have to have 4 sodium molecules reacting with 1 oxygen molecule to form 2 sodium oxide molecules. Sodium has a valency of 1, oxygen has a valency of 2. When they cross over, it becomes Na2O. And we have magnesium reacting with oxygen to form magnesium oxide. Now magnesium oxide is a white powder. So if you write a chemical equation, it would look like this. We have magnesium reacting with oxygen to form MgO. Now let's just review back to what we just learned. We learned about reactions with metals and acids. Also, we learned about which acids don't react with acid, which metals don't react with acids, and also the reactivity of them.